Welcome to Near Tech. Today, we're diving into one of the most fascinating and potentially revolutionary concepts in future technology, the von Neumann Universal Constructor. This theoretical machine has the ability to replicate itself using raw materials from its environment, potentially transforming industries from manufacturing to space exploration. But how close are we to making this sci-fi dream a reality? Let's find out. First, let's talk about the origin of the idea. The concept was first proposed by the brilliant mathematician and physicist John von Neumann in the 1940s. Von Neumann, one of the foremost minds in the field of computer science and mathematics, envisioned a machine that could autonomously build an identical copy of itself. This self-replication process could, in theory, continue indefinitely, limited only by the availability of raw materials. The idea was groundbreaking because it challenged the conventional limits of manufacturing and resource utilization. Von Neumann is also renowned for his foundational work in computer science, particularly the architecture that underpins virtually all modern computers. The von Neumann architecture describes a system where the computer's memory holds both instructions and data. This design allows for the sequential execution of instructions, forming the basis for the development of programmable computers. His contributions in this area have been instrumental in shaping the digital world we live in today. So how does the Universal Constructor work? The von Neumann Universal Constructor would need a few key components: a replicator unit, a constructor unit, and a control unit. The replicator would gather raw materials, the constructor would build the new machine, and the control unit would oversee the entire process, ensuring accuracy and efficiency. These components would work in harmony to create a system capable of self-sustenance and replication, much like biological organisms. But why is this important? Imagine a world where factories can build themselves, significantly reducing manufacturing costs and increasing efficiency. Such factories could be deployed in remote or hazardous environments, producing goods without the need for human intervention. In space exploration, self-replicating robots could be sent to distant planets to build habitats and infrastructure before humans even arrive. This could drastically reduce the cost and complexity of space missions, making the colonization of other planets more feasible. Moreover, the implications for sustainable development are profound. Self-replicating machines could help address resource scarcity by efficiently utilizing raw materials and reducing waste. They could be used to clean up environmental damage, such as oil spills or plastic waste in the oceans, by creating specialized units designed for such tasks. The possibilities are endless. However, creating a true universal constructor is no small feat. There are significant technical challenges to overcome. One of the primary hurdles is developing advanced AI and robotics capable of performing complex tasks autonomously. These machines need to have the ability to make decisions, adapt to new environments, and perform a wide range of functions without human intervention. Additionally, the machine would need to be incredibly versatile, able to work with a wide range of materials and adapt to different environments. This requires advancements in materials science and engineering to develop components that are both durable and flexible. The control unit would need to have sophisticated algorithms to manage the replication process, ensuring that each new machine is built to exact specifications. Current research in nanotechnology and robotics is bringing us closer to this reality. Scientists are developing tiny machines known as nanobots that can perform specific tasks at the molecular level. While these nanobots are not yet capable of self-replication, they represent a significant step toward the development of a universal constructor. Nanotechnology could provide the building blocks for creating versatile and adaptable components for these machines. One exciting area of research is in the development of programmable matter. This is a type of material that can change its physical properties based on external stimuli. Imagine a material that can alter its shape, strength, or electrical conductivity in response to specific commands. Such materials could be used to create adaptable and multifunctional components for a universal constructor. Another promising development is in the field of swarm robotics. This involves the use of multiple robots working together to achieve a common goal. By mimicking the behavior of social insects, such as ants or bees, swarm robots can perform complex tasks through simple interactions. This approach could be used to create a distributed system of universal constructors that work together to build larger and more complex structures. Futurists have weighed in on when we might see the von Neumann Universal Constructor become a reality. Ray Kurzweil, a prominent futurist and director of engineering at Google, predicts that advancements in AI and nanotechnology will accelerate in the coming decades. According to Kurzweil, we could see the early stages of self-replicating machines within the next 20 to 30 years. This timeline aligns with the rapid pace of technological development we've seen in recent years, suggesting that what once seemed like science fiction could soon become science fact. While we are still in the early stages of making the von Neumann Universal Constructor a reality, ongoing advancements in AI, robotics, and nanotechnology are paving the way for a future where self-replicating machines could become a practical tool for humanity. Governments and private companies are investing heavily in research and development to overcome these challenges and bring us closer to this revolutionary technology. In conclusion, the von Neumann Universal Constructor remains a fascinating concept that could revolutionize multiple industries. From manufacturing and space exploration to environmental cleanup and sustainable development, the potential applications are vast. While significant technical challenges remain, the progress being made in related fields offers a glimpse of a future where self-replicating machines are not just a sci-fi dream, but a tangible reality. Thanks for watching Near Tech. If you enjoyed this video, be sure to like, subscribe, and hit the notification bell to stay updated on the latest in future tech. Leave a comment below on what future technology you'd like us to explore next.